So this is the second half to graphing quadratic functions. In this section, we're going to go over identifying the domain and range and going ahead and solving for those zeros so that you can graph a more accurate and complete quadratic function. So we've already gone over domain and range at the beginning of the year. You know that domain is the value for all your x values and range is all of your y values. Now the cool thing about parabolas is that the domain for all parabolas is always going to be the same. Okay, it's all real numbers. And the reason for that is if you have a parabola that opens up, if you continue to extend that parabola in the x direction, you know, it's just going to keep going. It's never going to stop. In both directions. So in the negative direction, it's going to continue to get wider. In the positive direction, it's going to continue to get wider. So that happens regardless if your parabola opens up or down. Okay, so if I continue to extend this, it's going to get wider to the left, wider to the right. So for that reason, your domain is going to be all real numbers. So there, you can express it as x for all real numbers. Remember that little epsilon there is for all. Or you can have it in interval notation. Remember this is going to be open parentheses here with the infinities because we don't know that value, so it's an open range there, or sorry, open domain. Now the domain is a little bit different, and that's where your minimum and your maximum come into play. So this is going to be kind of an outline setup that I'm going to give you for you to kind of know how you're going to set up your domain and range. Remember that when your parabola opens upward, your vertex here, like in the example here on the graph, your vertex is a minimum, okay, because that's your minimum value or your lowest value for y. So if you're looking at your parabola, it stops right there at that vertex, but it'll continue in the positive direction upwards. So if we were to write our minimum, we have all of our values for y. For the interval, whatever your y value is here at that minimum. So our y value here at this minimum or at our vertex, right, our vertex here is the point 0, 0, it's at the origin. It's whatever our value is for y. So 0, it's a closed bracket because we know that value, it includes it. And then it's just going to continue upwards in the positive direction. It just keeps going forever up. So our minimum value for y is going to be 0, and it goes to infinity, open parentheses. If I had a parabola that opened down, okay, and had a vertex right there at -4, -2, okay, that is a maximum. Okay, so when you set up your range for that, you're going to have values of y for the interval, negative infinity, because our lower bound or our lowest value for y, we don't know what that is because this parabola is going to continue to open in the downward direction. So you're going to have open parentheses, negative infinity, and then whatever your maximum value is, whatever your y is. Well, here our maximum value is -2. Okay, that's our value for y. Be careful. A big mistake that some of you guys will do is give me the x value, which is, you know, this -4 here. You'll look at this graph over here, and you'll see, oh, okay, it's at the point -4. And you'll put -4 right here. Well, that's not correct. Okay, you want to make sure that you know, if you want to, draw your little line all the way across and see what your y value is so that you know that you put your correct value in here. The same thing here. Okay, if your graph is here and it opens up, you know, it's still a minimum, but your value that you're going to use, it's not 6. Okay, it's going to be whatever it is at the y-axis, which is going to be 4. So the range there would be, you know, 4 to infinity. Okay, and I'll do a few more examples. So here's a quadratic function. I'm not going to go through finding all of these values. Okay, if you don't know how to do that, go back and watch the previous video. If you need to pause it, go ahead and do your negative b over 2a, figure all this out, but I'm not going to do it to save some time. So if we're graphing this, okay, I'm just going to do kind of a sketchy graph here. I know my vertex is at the point 1, negative 2. So I'm going to go ahead and plot that point here. Okay, so 1, negative 2 is right here. That's my vertex. Okay, that's my vertex. Now I'm looking at my value for a. Okay, so a is a negative, which means that it is going to open downwards. Okay, I'm going to have a downward parabola, which means my vertex is going to be a maximum. Okay, my axis of symmetry is the vertical line x equals 1. So I'm going to go ahead and sketch that line. Okay, it's just the vertical line that crosses through the vertex, so that's the line x equals 1. And my y-intercept is the point 0, negative 4, so it's going to cross right here. Okay, so that's 1 unit that we moved over here, so we can reflect it 1 unit on the other side of the y-axis. Okay, so I can put another point right here. Okay, so now I have my points, they're symmetric. I can connect my dots, sketch my graph. Okay, so there we have the graph of this parabola. On the exam, I'm not going to give you these numbers over here. Okay, so make sure you know how to find them. So let's go ahead and talk about the domain and range. Remember that the domain for all parabolas is all real numbers. So we know that it's any value for x belonging to the set of real numbers. Now the range is a little bit different. Okay, it's going to be any value for y belonging to the set, and then we have to define the set. Remember that if it is a maximum, you're going to have a closed bracket over here and an open, sorry, I have it backwards. Remember that when you do your sets, you have your minimum value here and your maximum value over here. So you're going to have an open bracket here and a negative infinity, because this parabola is going to continue in the downward direction forever. Okay, so our maximum value is going to be negative infinity down here, or I'm sorry, your minimum value, your lowest value for y is going to be negative infinity. So that's what we're going to have over here on the left hand side. On the right hand side, we're going to have a closed bracket and whatever our value for y is at the vertex. So if our vertex is at the point 1, negative 2, okay, which I already have graphed. If you're looking at the graph, you just draw your little line over here, okay, and our value there is negative 2. And that's it. You're looking for the domain and range, that's what it's got to be. We'll do one more example. Once again, you need to know how to find these numbers. I'm not going to go over it right now. Watch the previous video if you need to, because you're going to have to know how to do that for the exam. Alright, so let's just plot what we know. We know that the vertex is at 1, negative 2. Okay, so 1, negative 2 is going to be right here. That's my vertex. I'm looking at my value for A. A is 1, so we know it's going to open upwards, which means this here is going to be a minimum. Our vertex is a minimum. Our axis of symmetry is the vertical line x equals 1, so we can reflect our points across that. So that's the vertical line x equals 1. Our y-intercept is 0, negative 1. Okay, and remember we can reflect that point across the y-axis. We have our 2 points. Connect our dots, draw your graph. Now in the next examples, I'm going to show you how to solve for the zeros. Okay, so you'll have like the point here and here. Okay, so you can have a few more points to draw a better graph. So here we have our graph, and we're going to find our domain and range. Domain for all parabolas is any x belonging to the set of real numbers. Okay, or you can put x belonging to the set from negative infinity to infinity. Either one is fine. Now our range is the one where you have to set it up. It's any value for y belonging to, and then you set up your whatever your set is going to be. minimum value on the left, maximum value on the right. Now our maximum value here, you see that your parabola opens upwards, so it's going to keep going in the positive direction all the way to infinity. That's your maximum value for y. So you're going to have an infinity over here, open parentheses, because we don't know what that is. Close bracket over here on the left, and whatever our value for y is at the vertex. Now that happens here. Okay, our vertex is the point 1, negative 2. Our y value is at negative 2 right there. So your lower bound there, or your minimum value for y is negative 2. Here's your domain and range. We'll practice more of this in class tomorrow. So, just go over the videos one more time and make sure you understand where I'm getting these numbers from. Okay. Now, in this last example, we're going to go ahead and find the zeros. Okay, so to find the zeros, you have to solve the equation. Now you can do that by factoring using the quadratic formula, completing the square, factor using bottoms up, factor using grouping, whatever makes you happy. I'm going to use the quadratic formula because it's quick and easy and you can just plug it into your calculator and figure it out. Now this is the example from the previous page. So if you didn't write it down, we know that our vertex is at 1, negative 2. Our axis of symmetry is the vertical line x equals 1, and our y-intercept is at the point 0, negative 2. Okay, so let's go ahead and graph that. We already know what our domain and range are. Okay, vertex is at 1, negative 2. We know that our y-intercept is at 0, negative 1. Negative 1, sorry. Our axis of symmetry is right there, which means we can reflect our point here. Now, before we graph it, we need to find our zeros so that we know where it's going to cross. Remember your zeros or your solutions, okay, or your x-intercepts happen wherever your graph crosses the x-axis. Okay, so we had a graph that looked something like this. Okay, we have to find these points here. Where are they going to cross? Well, that happens when y is equal to 0. Why? Because it happens here on the x-axis, and any point that you choose on this axis, y is going to be equal to 0. So we can actually solve for that by setting our function equal to 0 and solving. I'm going to use the quadratic formula. So we know that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's go ahead and identify our values for a, b, and c. A is 1, b is negative 2, c is negative 1. We plug them in. Our values for x are equal to negative b, always use your parentheses, plus or minus b squared minus 4 times a times c. Now be careful that you include that negative. A lot of you guys are missing that, and it's going to mess up your number here. 2 times a. Now, because our parabola opens upwards, you know that it's going to cross the axis and you're going to have zeros. So you should know that your value underneath the radical should be positive. If you get a negative number, it's because you forgot a negative, okay? And that should be like a red flag. If you get a negative under the radical, but you've graphed it and you know that it crosses the x-axis, then you did something wrong in your math. Okay, so let's simplify this. The double negatives give you positive 2 plus or minus. Negative 2 squared is positive 4. 4 times 1 is 4, times negative 1 is negative 4, so we're going to have a double negative there, all over 2. Keep going. 2 plus or minus the square root of that double negative is a positive, plus or minus 8, all over 2. And then that's going to split into your two problems. And what I would do is just plug this into your calculator so that you get a decimal, so that you know where it goes on the x-axis, because you're not, you know, even if you simplify that radical, it's going to be difficult for you. So just plug it in. We have 2 plus the square root of 8 over 2. I'm just going to plug that into the calculator. So you have 2 plus the square root of 8 over 2. That's going to give you 2.4. Okay, and if you do the other one, 2 minus the square root of 8 over 2, just plug it into your calculator. Divided by 2. That's going to give you negative 0.4. Negative 0.4. And that's going to be your values of x where they cross the x-axis. So your solutions, or your zeros, okay, and I'm going to write them over here, are the points where x is equal to negative 0.41 and 2.4. So if you write them as points, that's the point negative 0.41 comma 0 and the point 2.4 comma 0. Okay, so if we go over here and graph them, negative 0.4, okay, is going to be, you know, close to the half mark over here on the left, and 2.4 is going to be, you know, right around 2.5. So now you have, you know, a few more dots that allow you to graph a better, more accurate graph. Okay, we'll go over this a little bit more in class. Feel free to find the zeros of the other examples if you want a little bit more practice. Let me know if you have any questions. Other than that, this is it for this section, and you can go ahead and work on the Khan Academy homework that's due.